In this video, we're going to learn about concentration, and we'll learn how to calculate both percent concentration and molar concentration. First of all, we should talk about why we're studying solutions at all. So a knowledge of the properties and uses of solution is important to the study of chemistry. And there's a couple of reasons why this is. A lot of the substances that we use in labs are much easier to store and to use in solution form. So we'll get our solutions or our chemicals in a solution form rather than in a solid state. Another thing is that many chemical reactions will take place only when the reactants are in solution. So we have to have solutions and know about solutions to be able to perform many of our chemical reactions. So first we want to go over a little bit about some terms that are helpful to know. So solution, solute, and solvent. So the solution is the whole thing. So that's the solute dissolved in the solvent. So the solute are the particles that are being dissolved in the liquid, which is the solvent. So most of our solvents in our chemical reactions that we'll be doing will be water. So water will be our solvent, but a solvent could be many different chemicals, but water will be our primary solvent. And our solute will be whatever we're dissolving in it. So if we had a saltwater solution, our solvent would be the water and our solute would be the salts. And all together it would make up the salt solution. So calculating percent concentration is relatively straightforward. It's just equal to concentration, or C, equals the volume of solute divided by the volume of the solution. We usually measure that in milliliters, times 100. Or you can also find mass volume concentration. So the concentration would equal the mass of the solute in grams divided by the volume of the solution in milliliters times 100%. So now we're going to practice calculating percent concentration with a couple of examples. So the first one is, what is the concentration of a solution containing 20 milliliters of sodium chloride in 180 milliliters of solution? So C equals the volume of solute divided by the volume of solution times 100. So that in this case is going to be 20 milliliters. We need to make sure that our units match up. So if it were the wrong units, then you would need to convert one to match the other. So 20 milliliters divided by 180 milliliters times 100. So we'll put that into our calculator. So 20 divided by 180 times 100, and that equals 11.11%. So that would be our percent concentration. So now we'll do a second example. This time we'll be calculating the mass volume concentration. So in that case, concentration is equal to the mass of the solute over the volume of solution times 100. So that's going to be equal to 40 grams in 200 milliliters times 100. And we put those numbers in. So 40 divided by 200 times 100, you get 20% concentration. So our next way of calculating concentration is molar concentration. So in this case, molar concentration is C equals N over V. Some of these units or symbols should be familiar. I put this little triangle here. So we're already used to Twin Peaks. The mass over molar mass equals moles, and moles are equal to the number of particles divided by Avogadro's constant. I've added a bottom part to this triangle now. So this is our concentration triangle. So C, concentration, is equal to moles divided by volume. So in that, our we need to highlight a few things to keep note. This is volume, and that's in liters, just like mass is in grams. That will be important. Concentration is moles per liter. That's our concentration. Remember, the little n is our moles. This is molar mass, so grams per mole. And we probably won't be using the other side of the twin peaks, but this is number of particles. And this is Avogadro's number, which is 6.02 times 10 to the 23. So just be sure when you're performing these types of calculations that you're using the correct units at all times. So now we'll work our way through our first example. So the question is, what is the molar concentration of 15 grams of sodium chloride in 250 milliliters of water? So the first thing that we're going to need to do is find out the molar mass of sodium chloride, because to calculate the concentration, we need to know the moles. We don't know the moles yet because all we know is we have 15 grams of the solute, sodium chloride. So our first step, as I said, is to calculate the molar mass. So the molar mass of NaCl is equal to 23.0 grams per mole plus 35.45 grams per mole. And we'll add those together. So we get a value of 58.45 grams per mole. So now that we have molar mass, we can calculate the number of moles. And remember, the number of moles is equal to the mass over the molar mass. So that's equal to 15.0 grams divided by 58.45 grams per mole. So we'll put those numbers in. 15 divided by 58.45 is equal to 0.2566 moles. So now we want to find out what is our molar concentration. So we now need to take those values. So C equals the amount of moles divided by the volume. And the first thing that we notice is our volume is not in liters, it's in milliliters. So we need to convert that. So we would divide our 250 milliliters by 1,000, or to move our decimal place over 3 points to the left. So our volume is equal to 0.250 liters. So now we can calculate our molar concentration. So we put in our moles, it's 0.2566. And we can put in our volume, 0.250. So that's moles over liters. And it's just going to be over 1. So it's 1.02 moles per liter. So that's how you calculate molar concentration.